If you could start the recording. Thank you. Okay, hi everyone. Welcome and thank you for joining another ARD community webcast. Today our topic is harnessing the power of model-based testing. On the phone today we have James Walker, who is the manager of software engineering for ARD, and Josh Taylor, who is the product owner for ARD. They're going to be doing a presentation as well as a short demo today. If you have any questions as we're going through the session, please feel free to enter them into the chat box and we'll get to them as soon as we can. If we don't answer your question during the session, we're also going to pause at the end, so we'll get to it at that point if we don't get to it before then. Okay, I'm now going to turn the call over to James. Take it away, James.
Thank you very much, Melanie. So good morning, good afternoon, and good evening, everyone. As Melanie says, we've got a very exciting session today, which is automating the automation, harnessing the power of model-based testing. So as Melanie said, we've got myself and Josh on the call, and we've also got Edward Byrne, who's our automation engineer for ARD. And we're going to go through and cover a few things today. Firstly, we're going to start off with a few slides. I really want to talk a bit about traditional testing, some of the problems we experience in the software development lifecycle. We then want to go through just a few points of from our experience in the field, how we perceive successful automation being implemented. And then want to discuss model-based testing for automating the automation. And then we're going to kind of go into more of a demo. So as I say, the slides should take about 20 minutes. And then Ed's going to give a demo about some of the usage of how we use Agile Requirements Designer in our own development team and how we use it for our own automation functionality. And then finally, we're going to wrap up with some questions. Okay, so, whenever I think of software development, at least from my own experience, often the story starts with going into some project management system, right? And this is where, my requirements live. And it's always one of those things where, you go in there and you either, more often than not, you come out with some kind of headache because there's this huge wall of text. It's very difficult to understand, what kind of software I need to build from this requirement that's been given to me or assigned to me in the system. And we've done a number of case studies around this, and actually what we've found is that requirements typically are very bad, okay? And you'll see here that we have a whole bunch of statistics based on a case study we did. And basically what we found was that typically requirements contain a lot of ambiguities, and more often than not, these ambiguities end up in the resulting software that's produced. And in actual fact, there's a little statistic down there where over 50% of all defects found in production are introduced in the design phases and the requirement phases, stemming from poor requirements given initially. So, quite a big number there. Now, manual test case design, we go from those poor requirements, we implement them, and then, we loop back around, we take those requirements, and in some shape or form, we generate some test cases, which make sure that, the software we produced should, do what the requirements initially said it should. Now, some more statistics here based on some field study that we've done in our experience in the field. Manual testing is a time-consuming and error-prone process. We often find it's unsystematic. If you go to your testing team and you ask them how they're generating their test cases, usually you get a very stern look back because, almost intrinsically it was done in some kind of random phase. Often there's no real notion of coverage. Over-testing and under-testing is fairly common. And, really some other challenges here. There's no linkage to test data. And additionally, when the requirements change, it's very difficult to trace back and, figure out what test cases were affected. So often what happens is that, automated testing is kind of perceived as this holy grail solution to all testing. But really, the problems associated with manual testing kind of propagate through to automation testing. And really, if anything, the problems we see with automated testing are worse, if anything. So automated testing, revolves around heavily scripted frameworks. So instead of, writing these nice, plain textual step representations for a test case, we're writing some code instead. And this is usually done manually as well. So, there's no notion of coverage. It takes a lot of time to produce these. Often it's random, the test cases which are selected. Along with, maintaining this huge collection of scripts, when the requirements change. So alternatively, playback and record solutions are sometimes proposed. The same with scriptless automation frameworks, where we see keyword-driven frameworks. But essentially, we always end up going back to this central point where we're still doing, the same kind of test case design as we did with the manual, test case selection process. So, just to kind of take a step back here and take a little think about successful test automation. Really when we're creating our tests, and this kind of applies to manual testing as well. So although it says automation, I would consider these, essential processes for any kind of testing in general. So firstly, our tests need to be modular. Test cases should be reused without, having to rewrite or reinvent the wheel every time we write a test case. So if we think about, some kind of system which exists, perhaps some kind of travel system, embedded in that travel system is an authentication process where users have to go in there and log into the system. Now, this authentication process is used at almost every single facet of the system, whether I'm going through and I'm, ordering some kind of holiday, or I'm going through to the checkout process, or, I'm viewing something that I've booked already. That authentication process is hooked in at every stage. So, really with modular test case design, what I'm saying is that these are my tests which test the authentication system, and I'm going to use them, use those test cases, drag them in wherever it's appropriate. So I'm minimizing, the amount of rework which is being done. All tests should be maintainable as well. Now, one of the core things about maintainability here is having traceability between requirements and test cases. So really what you need is a mapping between, the initial requirements, whether they live in Rally, Jira, some kind of project management system, or whether they're physical or whether they're, textual based. There should be some kind of traceability matrix there where we can go backwards and forwards to be able to say, hey, these test cases failed, which requirements did this affect? And equally, if the requirements change, which test cases need to be updated. So this is all about kind of minimizing the amount of cost and also making it a lot easier to trace backwards and forwards between those elements. The third point we've got here is having a notion of coverage. So, being able to take some requirements and say, given the tests that I've generated, what amount of functionality am I actually covering with those tests? And this is kind of a common phrase which we use in the Agile Designer team is we want to be able to minimize the number of tests while maximizing the amount of coverage. And the goal should always be to get the maximum amount of coverage as I can out of my test cases to make sure that we're hitting every part of that requirement that we're testing, to make sure the system does what it should. The final point we've got there is getting the right data at the right time. I would say this is probably one of the biggest challenges in any kind of testing, is being able to match and find the right test data to use at the right time to make sure that when we're executing that test case, every single field is set as it should be, so when we get that expected result, it is actually the expected result that we were testing against. So this is where I want to loosely kind of talk about model-based testing in general, and then dive into test automation. So let's take a little step back and think about some other fields and disciplines and how they go about, creating, physical entities in their domain. So one of the examples we've got here is, we're going to design a house, okay? And the customer goes out and they've designed or they've described what they want their dream house to be to an architect, okay? And it's the architect's job to then go away and turn this this dream house into a reality, okay? So we've got some very loosely based requirements there. So the person whose house it is are about to have a baby, okay, and they want to live in the beautiful house with their family where they can all live comfortably. They need a house to have 2 bedrooms, 1 kitchen, 1 living space, 1 dining room, 1 TV room, and 1 bathroom. And the house needs to feel spacious and warm, okay? Now, the homeowner has come in here firstly, and they've drawn down some very loose sketches of what they want, the layout or the plan of the house that they want to be built, okay? So we've initially started with some very basic requirements for the house here. The architect has then come in and, taken these loose, more conversible between the builders who are going to come in and realize this plan. The interior designer then comes in. Oh, okay, sorry about that. Is that any better, Melanie?
You sound okay now, yeah.
Okay, just let me know if there's any more problems on the line.
Okay.
So just the different personas, who take their part in designing a house. So firstly, we have the homeowner who comes in and draws some very loose plans about what they would like the house to look like. Comes in and draws some more concrete or solid plans to work from, okay, with actual physical dimensions in there. Designer who comes in and decides which rooms are the bedrooms, what furniture is going to go in each room, and the general layout and the general feel of the house which we're designing. Final example, we have an electrical engineer who comes in and decides where all the lights and electrical fixtures are going to reside. In reality, there would be a lot more phases going on here. But what we're trying to, illustrate in this example is that, this asset detail as it passes through kind of revolve around the same, mantra as model-based testing. Okay, so model-based testing is a this has got low connection. Can you hear me okay still?
Yep.
Yeah, I can hear you fine.
Okay, great. Sorry, it was coming up saying it was a low connection there. That's fine. So yeah, model-based testing basically lets you define the behavior of a system under test. Okay, so what we're doing is we're creating a model of what the system is supposed to do. And then what we're going to do is we're going to take that model all the way through from design, we're going to take it through to implementation, and then we're going to take it through into test, and we're going to test that the actual system was developed, does what it was meant to do from those initial requirements. Okay? So if we loosely, in any software development team, the initial software design starts with some kind of requirement. And in this specific example, we're going to start with a product owner who initially draws down what they want their system to do. Okay, so you'll see here someone searches, they select some flights, they enter some information about the flights they want, and then they review and they pay for the flights. Okay. We've then got a modeler who comes in and overlays some more detail. Okay, so they're adding more value to the stream to remove ambiguity and try and narrow down on all of those layers and and different, logical functions which can happen to ending up at either, going through to the final process where we're paying, and also some of the validation parameters which are taking place. The third persona we've got here is the data engineer, who's then going to come in and overlay some data attributes on top of the model. We could overlay some virtual endpoints in here as well. Some test automation. So, in this examples, but really this is all about model-based testing. Okay, so we're coming in we're designing automation, which is what Ed's going to go into in more detail in his demo in a minute. So, yeah, let's pass this over to you, Josh, and we're using Agile Designer in our own team to automate our testing.
Yeah, that's great. Thank you, James. Can I steal the presentership off you so I can just show my screen?
Yeah, sure. There we go. Should be presenting now, Josh.
Great. Tell me if you can see my screen or not.
Looks good.
Am I good? Okay. Perfect. Okay. Hi, everyone. So we're going to show you a kind of concrete example of exactly what we're talking about. And what I'm going to do is I'm going to begin with an existing flow. So as James was saying, we were using this within our own team to do our own testing. So as we build features for ARD, we model the features, we add some test data, we have some validation in there, we add some automation in there, and then using our own tool, we can generate our automation scripts, and we can use them then to test our own tool. So in this exact example, I've got a model here which is describing one of the features we have of how ARD integrates with other tools. So for example, if anyone's ever seen the integration between ARD and ALM, or ARD and Agile Central, or Team Foundation Server, this model is describing that functionality. So for example, I have some processes here to just open up ARD, and then I log into one of these connectors. And for example, if I'm selecting Agile Central, I then have a list of import actions. So I can import user stories, I can import test cases. You kind of get the idea. So this flow is really describing what's possible with this one feature. And what we've done is overlaid on this flow small automation snippets. So for each process in this model, so for example, if the process is to open a flow, I just add a small bit of automation to that one process block, and that will facilitate opening that flow. So as we go through, obviously this flow is actually quite complicated, and we can cover lots and lots of functionality, and I can derive thousands of test cases from this one flow. So for our one example today, I want to focus on a single test case. And I'm going to show you this test case executing, and then we're going to show you a change the requirement which breaks our test case. And then on the reflection of that, we're going to update the model, which will automatically update our test case, and I can show you reactive automation, or automating the automation. So if we come into Path Explorer, so for those who aren't very familiar with this, so what we're really dealing with here is we have a model with a start point and an end point. And what we really care about is what possible ways can I get from the start to the end? And I can determine those by coverage metrics. If I say, I would like to cover every process block in my flow, or I would like to cover every edge in my flow, you can determine that. So by asking ARD, generate me the minimum number of test cases, which go from the start to the end, to get me the maximum coverage. So that in itself is really, really powerful. So by identifying the set of coverage you want, ARD will just give you the test cases for that exact need. So if we look at a test case I have already. So for this exact example, we're going to run a test case for the integration between ARD and ALM. And for this test case, all we're going to do is log into the integration in ARD. We're going to locate an existing test case, and then we're going to import that test case from ALM into ARD. So from our testing framework, we actually write everything using RunnerX. So we use RunnerX Studio to do our execution. And normally what most kind of people do is they open up RunnerX Studio and they write the code there. But with this modeling technique, you add the automation within ARD. So the only thing we really use RunnerX Studio for is an execution engine. So I'm just going to open up this test case right here. And this is a fully executable automation script, which I can send to RunnerX Studio. And what I'm going to do is just quickly export that one test case. And if I just close down these windows, and all I'm going to do is open up ALM. And actually, on that fact, I'm just going to hand it over to Ed. And Ed's going to show you that exact test case executing from RunnerX Studio.
Okay, so are we executing the test case? Right. So if we go to here, so RunnerX is a tool that you can create and execute scripts, basically. So here's the test case we created. And okay, so if we click run, all right, so let's just go.
Okay, so if we just prime ARD, so it's a bit unusual that we're using the tool to generate the test cases that we use to execute our test against. So if we just reset ARD back to how it's normally used, so we can delete these fields, great, and we'll close the flow, go back, and come back to RunnerX, great. So we're just going to execute this test case. So hopefully now we can show you that this test case is going to run, load into ALM and import an existing test case. And once we've shown to do that, we're going to show a change in the requirements. So I'm just going to open it up. It's logging in. Now you can see it's expanding through ALM's tree, found a test case, and it's just going to select that test case and import it in. Great. So very, very simply, that one single test case we can see is just identifying something very, very simple. All we're doing is finding a test case from ALM and bringing it in. Now, in this example, we want to show you how automation can react. So what we're going to do is introduce a new feature into ARD, which will break our test case. So, and the feature I want to introduce is this panel we can see on the right-hand side. This panel allows us to log into the ALM integration. It allows us to navigate and allows us to import. So until this point, we've assumed that this panel is always static and always exists in the product. So we're going to add a feature to the product which says that this panel can be hidden. So this panel isn't always visible. So the real issue we have is when our automation script comes along, and obviously our automation scripts aren't smart enough to kind of analyze this kind of change, is that the automation script is going to come along, assume that it needs to find the login dialog, in which case it's not going to be able to find it. So we're going to have to make a change to the model to account for that change. So if I show you that test case failing first, so if I come into ARD, I'll just remove that single field, come back to RunnerX, and I'm just going to come in, run that same test case. And hopefully we'll be able to see that now as we start the flow, it's not going to be able to find that login dialog, and then the system's just going to time out. So our test case is broken, our test case no longer works. So really simple, we're just going to kill that test case in RunnerX. Great. And let's just open up our ARD flow, and we're going to make some changes. Now, when you think about how you need to change automation scripts to reflect a change in the requirements. That's actually quite a lot of work. So, and it's always compounded by how many test cases you have. So if you have 1,000 test scripts, you've got to go away and update every single one of them. Where with this example, you update a single page, you update the model. And it doesn't matter how large the change is. So for example, in this one feature we're showing you today, it's just a small feature change. Maybe we can do this with adding a block, adding some logic to our model, and having our test change. If the change was much, much larger, if our change required many more processes, many more decisions, and a lot more logic, yes, you would have to change the model and add the pieces in. But realistically, your 1,000 test scripts, you don't have to go away and change each one. The model will automatically update those for you. So Ed, if I pass it over to you, would you mind updating this ARD model just so we cover our new functionality?
Yeah, so I created a flow to deal with this area. So if we connected that, all right. So now it's because, oh yeah. So we don't know what integration it is. So we need to tell them specifically which one. So right. So I've called it a variable in this flow tool connect box part of the box it's looking for, and to make it appear, one of the buttons on the side, I've called it selected connector button.
So really what we're showing you is quite simply, we're adding a single process in, which simply clicks a button, but also to do that action, we need some test data. So not only are we adding automation, we're also adding test data, and we're editing the model. So we're doing quite a complex change. Visually, it's only a single item. So now with that one change, we're going to go in, we're going to see, okay, our test case has changed. We're just going to fix that. And we say, okay, great, there's new logic. And from that one test case, what we're going to ask ARD to do is, okay, go through and reassemble my new automation script. And like I was saying earlier, that once you make that single change to the model, all the automation scripts automatically test the new change in automation. And this can be really, really powerful. So if we show you the one change within Reactive Studio, I think for us, I think it's 3 or 4 line code change actually. But as I was describing earlier, this small change can affect many lines of code, many scripts. And realistically, the only input you need is into the model. So if we quickly show you where our automation is, so this is our new automation code now, which checks if that item is visible. And then
if it's not visible, and then it will click onto it.
Exactly.
Otherwise, it'll ignore it.
Great. So how about if we export this now, and I just want to test this new script. And again, what we need to do is just close ARD down, just so we can test against it. And great. So while that saves, Ed, would you mind going into Ranorex and just opening that new script? Great. And if we just pop to the exact line that we care about. Great, great. So just highlight, that's line 34 there, so we highlight that. So we're just saying that if our login box is not visible, if our login box is not visible, then we want to click an item to make it visible. So this way, doesn't matter how ARD is set up, this test case is going to go through and pass. Brilliant. So if we just come back to ARD, and now importantly, if we just click on the ALN connector, we just make it visible, and we're just going to delete all these settings. Great. Now, in the exact same instance, we're going to make this item not visible anymore. And if we run this test case using our reactive automation script, we should be able to see that it'll make this item visible and then continue with the test. Here we go. It's launching, doing the nano step. Great. Now that extra bit of code that's gone in, and made that item visible so we can continue with the test. And like I said, I know I keep banging on about this, but it doesn't matter how many test scripts you have, that changing the model will change the rest of your test scripts. So the manual effort required to update your test scripts anymore is effectively removed. It's all about model management, and model management takes much, much less time than automation management. So I hope that little demo was enough to kind of show you the impact that ARD can make into this world and how much time and energy you can spend. And again, this is all on top of the existing benefits you get from ARD. For example, having a fully functional description of your system. So you get very, very good collaboration work. So you get very good coverage because you know what your system looks like. You can generate very, very good tests to cover exactly what you need. And then you also get this reactive automation just out of the box. So hopefully that's a good description. And as I can see in Ranorex, great, that's passed. I'm very happy. So on that note, I hope that was descriptive enough for you. I hope that we kind of showed the benefits in this demo. And on that note, actually, I just want to pass it back to Melanie just to see if there's any questions for us.
Sure. We don't have any questions as of right now, but just a reminder to everyone on the call, if you do have any questions, you can enter them into the chat box at this time. When you select two, please select organizers and panelists so all of us can see the question, please. Okay, I'm not seeing any questions. Do you guys have anything else you wanted to leave off on?
I don't think so. I think we've covered quite a lot, actually. So there's a lot of information in this one presentation. But really, you should be able to see the benefit of this with a very, very small model. So in this example, we use a very, very complicated feature in ARD to kind of show you. But really, you can get this benefit of much, much smaller models. So you don't have to invest the time in which we've invested into this. So you can see benefits very, very quickly.
Okay, so if you have any questions you think of after today's session, please feel free to put them in the community. We're always monitoring that space for any questions you may have. We're going to be posting the recording and the slides from today's session later today, so keep an eye on that. That'll be in the ARD community. We do have a few more topics coming up for some webcasts. We're looking at another session for September, so we don't have that posted yet, but please keep an eye out and we'll get that posted to the community shortly. Other than that, thank you everyone for joining. Thank you, Josh, James, and Ed for a great presentation, and I'll see everyone out in the communities. Have a great day, everyone.
Thank you, everyone.
Thank you, everyone.